In this chapter, we're going to talk about mainly two functions, exponential function and a new one called logistic function. So first, let's talk about the exponential function. Exponential function, as you may have remembered from last year, it's this function here, a times b to the x. So reason it's called exponential is that x is in the exponent position. So this b, where x used to be, this is called the base. So the base to an exponent or 2x determines the parent function of the exponential function. And then a here, in most cases, this is the initial value. In most cases, but it is just kind of the coefficient of the function. So kind of like what I mentioned before, how is this different from the power function k times x to the a? And you can see that the main difference is x is in a different position. Before a was in the base position, now x is in the exponential position. So let's have you do this really quickly. 1, 2, 3. Which one is exponential function? Which one is power function? Power function means just like a monomial for a polynomial. And then what would be the base of that exponential or power function? All right, go ahead and check your answers. Now let's review really quickly how to evaluate exponential function. So for example, if the function is 2 to the x, then f of 4, remember f of 4 means put 4 in the x position. So this is going to be 2 to the 4th, and hopefully you remember this is 16. And same thing with the other ones. Let me just kind of review a few that is a little bit trickier. F to the 1, f of 1 half. F of 1 half means 2 to the 1 half. Hopefully you still remember 2 to the 1 half is square root. But basically, when you have a fractional exponent, then the base always goes inside. This part, the numerator of the exponent goes in as the exponent part, and then the denominator goes outside as the index. And we know that second root just means square root. So this is really just the same as square root of 2. So quick review. And then also this one, f of negative 3 halves. This is a little bit tricky because now we have this, and it's just a matter of how much you remember from last year, how you simplify. So maybe the first thing you want to do is just get rid of the negative exponent. So a negative exponent tells you it's in the wrong position, so you're going to put it in the denominator. And then 2 to the 3 halves means square root of 2 cubed, and then the 2 in the denominator means a square root. And if you kind of recall, if you want to simplify this, there's many ways. I think the fastest way to simplify this is to, if you don't want the root in the denominator, is to remember that in order for it to become a, you want to get rid of all the roots, that means in the denominator, you need to, if you were in here, then you want to get the fractional exponent to become an integer. So in order for 3 halves to become an integer, you need another 1 half, right? Because when you multiply two numbers that have the same base, you add the exponents. So this actually becomes 2 to the 1 half, and in the denominator, 2 to the 3 halves plus 1 half. 3 halves plus 1 half is 4 halves, which is 2. So this becomes 2 to the 1 half over 2 squared, which is 2 to the 1 half over 4. And then let's just simplify it all the way. Square root 2 over 4. Now, let's say that you have to write an actual equation, an exponential equation, and you're given some values, whether that is from a table or from a graph. So what we want to do is first you gotta memorize the exponential function, the basic function. So a times b to the x. And then, so for example, this one here. So you have 4 points. So what you want to do is kind of think about it. In order to create this equation, y and x obviously have to stay because if they don't, you don't really have an equation. So the only two variables that you really need to figure out is a and b. Now think back in Algebra 2. If you have two variables that you're trying to figure out, how many equations do you need? You need two equations, right? So then you have to create two independent equations from something, so in order for you to solve a and b. So from this graph here, you can just randomly choose any 2 points. I'm going to choose these two because they're all integers, so hopefully that would be easier for me to solve. So 0, 4 just means x is 0, y is 4, and then same thing with 1, 12, x is 1, y is 12. So what we can do here is just create two equations with these 2 points. For example, 0, 4. So when you put in 0 for x, you get y as 4, and then we're putting it into this equation because we're saying exponential equation is the best model for this shape. So 4 is equal to a times b to the 0. So that's my first equation. And then the second equation with 112, we're going to get 12 equals a times b to the first. Okay, when you're doing this, please be careful with order of operation. Make sure you still follow the PEMDAS rule. So 4 equals a times b to the 0. B to the 0 is 1, so that just means 4 is a. And here, 12 equals a times b to the first. B to the first is just b. So 12 is ab. And then we know that 4 is a, so b must be 3. Therefore, Therefore, we can just say that y is equal to 4 times 3 to the x. Now let's review. Can I write this as y equals 12 to the x, basically multiply this together? No, you cannot. So in an exponential equation, this part is the parent function, and this part is the coefficient in front of the parent function. And therefore, 4 is really like the vertical stretch and compress. So you cannot take a coefficient and multiply by the entire function and multiply the two numbers together. That is not allowed. So make sure you don't write 12 to the x. Okay, let's have you practice. This time you have a set of values and then they tell you that this is another exponential equation. So go ahead and give this a try and come back and check your answer. All right, please go ahead and check your answer, this one here. Now let's talk about exponential growth and decay. How do you know when an exponential function is going to grow? Grow means that it looks like this. It gets bigger, y gets larger when x gets larger. Exponential decay means that as x gets bigger, y is going to decrease. So how do you know which one is the shape for which one when you look at a function? So first, when the base is, that's b, when it's bigger than 1, it's going to be an exponential growth function. When the base is between 0 and 1, it's an exponential decay function. When the base, let me write this. When the base b is less than 0, it's not exponential function. I guess you can say less than or equal to 0. So first, if the base is 0, you have 0 to everything. It's just always 0. So there is really no function at all. If it's less than 0, it's a negative number. And then if you kind of think about it, it's going to oscillate between positive, negative y values, and so that's not an exponential function. All right, let's have you try this one really quickly. Whether the function is exponential growth or decay, remember you're looking at the base. All right, number 1 is decay, number 2 is growth. All right, now really quickly, let's talk about transformation again. So same thing as all the other ones. So A, again, is the vertical compress or stretch, and we have b to the x, that is now our parent function, and we still have the minus h part. And then this year, we have the new thing here, which is c, that is the horizontal stretch or compress, and then we always have a plus k outside of the function. All right, let's do one for example. Number 1, g of x is equal to e to the 2x. So the first thing is you want to figure out what the parent function is. Remember the parent function is b to the x, the base to the x. So in this case, it is e to the x. So then the question is, what does the 2 do? So you got to ask yourself, is 2 inside the function or is 2 outside the function? Well, 2 is definitely inside the function because it's inside e to the x. And so it's a number multiplied to x inside e that has to do with horizontal stretch or compress. It is going to be something with horizontal, but it's in the wrong position. So what we want to do is, if you recall, that 2, whatever that number is that's multiplied to, has to be in the denominator. And since it's not in the denominator, we need to force it in the denominator. And to do that, we put the reciprocal of 2 in the denominator. So c is actually 1/2. And so this is, horizontal compress by 1/2. All right. Let's do number 2 together. So first, again, parent function. Which one is the parent function? Which one is b to the x? That is 3 to the x. And so the 2 is outside of the function, so that has to do with vertical something. The negative and the plus 4 inside, that's the tricky part. So what we want to do now is we want to change the function a little bit. So 2 times 3. And then if you recall, you got to take out whatever is the leading coefficient of x. So I'm going to take that negative out. So this is really minus 4. Now look at the function and write the transformation. All right, go ahead and check your answer. So again, you need to make sure you factor out the negative from x, or else you will be moving to the wrong position. We're going to skip number 3. Number 3 is very easy. I'm pretty sure you have this down.